And we left off on example number 5. So this is the type of stuff that you're going to need to know how to do for the quiz tomorrow. You're going to have to do those row operations. So just coming back here and just reviewing for a quick second, we went through and we reviewed some of the ideas that you would have gone over in 1010, that you would have reviewed in 8.1, how to solve systems of equations, 2x2 systems, and so forth. I solved this one in kind of a weird way. Same thing here. You'll notice that I wrote some of these down in a little bit. I mean, that's a weird thing to write down, 0x plus 0y. But if you take a look at this one and this one right here, I think you might see something like that again in the work that we've done. So we talked about how we can use a matrix. A matrix is a rectangular arrangement of numbers to kind of keep everything nice and neat and organized. We talked about the dimensions, the rows and the columns, the entries, and all that sort of stuff. We talked about how we can name the dimensions and how we can name, the element there. So the 2, 1 matrix, or the A2, 1 entry, is the one that's in the second row, first column. We talked about how we can write down a coefficient matrix and a column matrix. And then this is what we're usually dealing with, at least in this section, is what we call an augmented matrix. And this is what keeps things organized for us. X column, Y column, Z column, and then an answer column over here. Okay? And we can use some operations that we get from a topic called linear algebra. These are called row operations. And there are 3 operations that we typically use. There are actually more, but this is enough for right now. You can take any 2 rows and swap them. Just literally move places with them. Okay? Because all you're doing is moving an equation, right? Okay, you can replace a row by a non-zero multiple of that row. So you can take a row and just times it by 2 or multiply it by a half or something like that. And then you can also replace a row, and this is what we do most of the time, replace a row with the sum of that row and a non-zero multiple of another row. Okay? A constant multiple is what we call it. And so we went through and we did a couple of those, just very simple operations. Did this one. Okay, again, -2 times row 1, add it to row 2. Row 2 is the one that gets changed. We did these steps in order. We wrote down an augmented system and we solved this. And we had these kind of keys, little ideas that would make it a little less frustrating. So we make sure that we go slowly, keep things nice and neat and organized. Avoid fractions if you can. Sometimes you can't. Most of the problems you can. Okay? Go column by column and get the ones to make get the ones first, and then use those to make the zeros. And we talked about with a 3x3, which if you can solve a 3x3, you can solve a 2x2. The goals are in this order. Get that 1, use that 1 to make those zeros. So first goal, second, and third. Fourth goal is right here. Make the 1 and then use that 1 to make those 2 zeros. Make the 1 here, so that's going to be the 7th goal, and then use that 1 to make those zeros. And by the time you get done, we call this reduced row echelon form, and you can look at it and you can just read off what the answer is. Okay? So, we got to right here. We had written down our steps after we wrote down the augmented matrix. We kind of showed a little bit of work, and this is where we were right here, and we said we're going to take row 2 and we're going to add it to row 1. And then I said, see if you can finish that. So let's go ahead and pick up where we left off. We're literally just going to take row 2 and add it to row 1. Now, which row gets changed? Row 1 does. So row 1 is going to be 0 plus 1. That's a 1. 1 minus 1. That's a 0. 6 plus -1, or 6 minus 1, that's going to be a 5. And then 20 minus 4, that's going to be a 16. Now, does anything happen to the other 2 rows on this step? Nope. Okay, we kind of like those. That was getting us pretty close to reduced row echelon form. So this is 0, 1, 6, and a 20. And this is a 0, a 1, and a -1, and whoops, 0, a -1, and a -3. Okay? Now, right there, okay, there are how many goals already taken care of? 6. How many more do we have?
3.
Only 3, and the 7th one is pretty easy, because I need to turn that into a positive 1. So don't say anything out loud. Just think for a second, how could I change that to a positive 1? Think about the rules. The rules are on the previous page. You can switch rows. That's not really going to help us there. You can multiply a row by a non-zero constant. So you can take a row and just multiply everything by something. Or you can take another row, multiply it by something, and then add it to that row. Of those three steps, which one's going to be the easiest here? Multiply a row, right? So I'm going to take row 3, and what am I going to do with it? Times it by a -1. And this is what I end up with. Now, I haven't messed with this one at all. But I did go through and I changed this one. So this is now a +1, and this is now a +3. Okay, are there any questions there? Okay, you with me? Did anybody get this one done? Okay, one of you, excellent. Okay, I want you to take a look at these two lines right here. 0, 1, 6, 20, and 0, 0, -1, -3. Okay, now what column is this again, that first column? X, Y, Z, answers, right? 0, 1, 6, 20. 0, 1, 6, 20. Right there. This one, if we read from this row, 0, 0, -1, -3, isn't that the last row in our augmented matrix? So these two equations that we used when we were solving this using an old technique that we learned from 1010, you know, I wrote down some extra stuff, are represented by those lines right there. Okay? So literally this means no x's, no y's, -z equals -3. Now take a look right here. Take a look at this one. So let me erase that highlighting there. Take a look at this one. What does that last equation mean? It means z equals 3. Okay, so right at this point right here, we could say, hey, I know z equals 3. If I know z equals 3, can I find another variable by substitution? Sure. Take a look at the second line right here. What does that line right there represent? What equation is that?
Y.
That represents y plus 6z's equals 20. So I could plug in a 3 right there. What? Plug in a 3 right there. That's y plus 18 equals 20. Move the 18 to the other side, and what's y? Y is 2. Now, take a look at that first equation there. What does that one mean? That means x plus 5y equals, sorry, 5z. Thank you. 5z equals 16. If I plug in a 3 for the z, that's x plus 15 equals 16. So what's x? X is equal to 1. Now, is this in reduced row echelon form? Do I have 1s down the diagonals and 0s everywhere else? No. Okay? So let me show you what happens if we finish this off. Remember, the idea is to get the 1s in each column, use the 1 to make the 0s. I've got goal 7 taken care of. Now let's take care of goal 8 and 9. So let's say I want to get rid of the 6. I'm going to use the 1 to make that a 0. Don't say anything out loud. I'm going to write a command that looks very similar to this right here. I'm going to take row 3, and what am I going to do with it? Multiply by -6. Add it to row 2. So this is going to be 0, 0, -6, and -18. When I put those together, now, does the last row change? Nope, we like that one. We're going to keep that one. But this one does. 0 plus 0, 1 plus 0, 6 minus 6, 20 minus 18. Well, where have we thought about 20 minus 18 before? There's that one. And then let's finish this off. Let's get this all the way in reduced row echelon form. I'm going to write down a command here. It's going to look very similar to the one up above. Again, I'm using the 1 to make that a 0.
It's just going to be
It looks exactly the same, except for it's going to be -5, and we're going to not add it to row 2. We're going to add it to row 1. So this is going to be 0, 0, -5, and this is going to be -15. So I get a 1 See how that doesn't screw up the 1 that we made? 0 plus 0. It doesn't screw up the 0. All it does is get rid of the 5, makes that a 0. And then this is going to be 16 minus 15, so this is a 1. Now, here is my augmented matrix. This is in reduced row echelon form. And the nice thing about reduced row echelon form is you can look at this and you can read off the answer. So there's only one 1 here. It's in this row in this position. So x is equal to 1, y is equal to 2, and z is equal to 3. So our solution, if we were to write this as a point, would look like this. X is equal to 1, y is equal to 2, z is equal to 3. Okay, are there any questions? Okay, raise your hand if you like this. Wow, that's pretty good, like 15%. That's amazing. Okay, most people don't. Oh, we're up to 20. Yeah, okay, we're not up to 20.
Doesn't that take longer than doing it?
Yes, it does. Okay. Takes longer for a couple of reasons. You have a lot of arithmetic to do, okay, which you do have arithmetic to do using, the standard elimination technique. Okay. With this, though, and I'll be the first to admit, does the logic behind it make sense? It just seems a little bit tedious. Okay. The reason we do things like this is because what if you were going to solve a 4x4? Or a 5x5? Which people actually have to do. No. Okay? The nice thing about this is you can teach a computer what these rules are. Okay? Or you could tell a computer to do this. If you understood how this game was played and what the process was, what the goals were, you could have a calculator or a computer take care of all the arithmetic for you. And then a 4x4 is really not that much more difficult than a 3x3. Because you just add another row and one more column. You get those zeros. You get that to be a 1. Use it to make the zeros and so forth. Okay? The process is very easy to replicate even with a more difficult and more complex system of equations. Okay? So this seems like it's making more work. And if it's only a 2x2 or a 3x3, I agree. It probably is. But think about what you have to do with a 4x4. If you were going to solve a 4x4 using the techniques that you had in 1010, you first have to eliminate one of the variables. You have to change 3 separate pairs of equations and eliminate the same variable to make a 3x3. Then you have to take that 3x3 and finally make it a 2x2. And then finally eliminate one of those so that you can get down to one variable. That can take a very long time. It is far more tedious than this. Okay? And really, if I were going to solve a 4x4, I'd use this before I'd try and do it, writing down all the x's, y's, and z's and stuff like that. Okay? It's a lot easier to keep track of. And what you'll find is, and I think I've mentioned this several times, you're to a point in math where you're learning stuff that's kind of opens the doors for some really cool stuff down the road. No one in their right mind would solve a system of equations using techniques that you learned in 1010. If you had other options, what we do is we have calculators and computers do them, but we don't do it by magic. We don't just plug it in and say, hey, just tell me what the answer is. You've got to understand how to do it. Okay? And this nice step-by-step logical process is how you'd solve something that's much more complicated. So if you can follow these and keep the arithmetic straight, and it can be frustrating, you want to make sure you're really careful, you're much better off in the long run. Okay? I agree, it looks like it's more complicated right now. Okay? But some people in here are going to be engineers, and you're going to do linear algebra, and you've got to be familiar with this, because once you get past a 3x3, it can get really, really complicated. Okay? So you want to have some tools that kind of compartmentalize. The cool thing about a 4x4 is it's the same game. You use exactly the same rules. Just take you slightly longer. Not a ton longer, though. Okay, any questions? Okay, that's the idea. We're just going to practice that now. So I want you to take a look at example number 6. It says, solve each system or state that it's inconsistent. So a lot of the work has already been done for us. We just need to know how to interpret this final answer. So this is an augmented matrix. If I were to look through here, what does that last row represent? X, Y, and Z have been eliminated. This side equals 0 and that side equals 4. Does that ever happen?
No.
Nope. So we would say inconsistent. There's no solution to that. Let's take a look at the next one. Ideas?
No. Zero equals
Okay,
zero.
not quite. Okay, this says that 0 equals 0. Okay, now if you've seen this before, you know that if we get two numbers that are not equal and no variable, we know there's no solution. But what if we have two numbers that equal each other? There are going to be infinitely many solutions. So here's what we say. Here's how we solve this. This means z can be any number you want. There are going to be infinitely many solutions. If you tell me what z is, I'm going to tell you how to figure out what x and y are. So take a look at this second row here, this second equation. What does it represent? 1y minus a z equals 2. So if I wanted to know what y equals, I'd move the z over to the other side and I'd say y equals 2 plus z. So if you tell me z is any number, you tell me what number it is, I'm going to tell you that you take that number and you add 2, and that's what y is. So guess how you find out what x is? Same thing. This one says that x plus z equals 5. So if I move that over, I get x equals 5 minus z. Okay, and there are our infinitely many solutions. They're all based on, or if you think about it for just a second, they are all dependent on what z is. You tell me what z is, I can tell you what x and y is. Okay? All right, let's take a look at the next one. You do know that z is equal to 2, so that's good. If you know z is equal to 2, by the way, does anybody recognize this? When you've got zeros down here in this little triangle there, it's called row echelon form. And the nice thing about row echelon form is you at least know what one of the answers is. In order to find the other answers, here's what we've got to do. That second equation means y plus z equals negative 9. So if I told you that z was 2, what's y? Negative 11. Or if we move that around, it would be y equals negative 9 minus z. What does that first equation mean? X plus y plus z equals 6. Okay, watch please. I'm going to do this a little bit differently. Everybody agree that that's what the first row represents? Okay, I'm going to say x equals 6 minus y minus z. And can you tell me what y is? So that's going to be plus 11. And what's z? Minus 2. So that's going to be 17 minus 2. So x is 15. Okay? So there are the three answers. Now, okay, if you're not thrilled about this, you have to at least get it into row echelon form. You've at least got to get goal 1, 2, and 3, 4, 5, and 7. Okay? So get 1s down the diagonals, 0 over here. Don't worry about it up here. You can make it look like this. If you want to go back and translate it into an equation and then solve it from there, that's fine. I would encourage you, just like I do with everything else. I mean, a lot of what happens in 1050, it's a bunch of brain stretching. Try and see if you can get it into reduced row echelon form. You can just read off what the answer is. There's no changing it back into an equation or anything like that. You just know there's x, it's 1. There's y, it's 2. There's z, it's 3. Okay, any questions? Okay, here's what we're going to do the rest of the time. We've got, let's see, 1, 2, 3, 4 problems left to do. Okay, on problem number 38. I'm going to give you a short head start on every one of the steps. If you can think ahead and guess the right step to do and do it carefully and correctly, you know how to do this and you'll do fine on the quiz tomorrow. Okay? The quiz tomorrow is going to be a 3x3. It'll be like the one that we just got done doing. Okay? So we'll practice on this one right here. The first thing you need to do is write down the augmented matrix. The augmented matrix is 1, 2, 5, 1, 1, 3. Now, I normally get a little bit lazy. I don't write the little line there. I'm fine without it. Again, keep things nice, neat, and straight. Keep them arranged really nicely. Then I'm going to look at this and I'm going to think, okay, I've got a couple goals here. Okay, I need you to stop and listen for just 1 second. A lot of people will look at this and say, hey, I've got goal 1 and goal 3 taken care of. You really want to focus on just the columns, because just because there's a 1 there right now doesn't mean it's going to stay there. So be careful with that. So I've got goal number 1 taken care of. Think about what goal number 2 is and how you can get goal number 2 accomplished. Go column by column. Be careful. Use the 1 in that column to make the zeros you need in that column. Okay, the 1 I'm going to use is in row 1, so I'm going to take row 1 and do what with it? Times it by a -1, and we're going to add it to row 2. If you wanted to say I'm going to take row 2 and subtract row 1, I suppose that would be okay, as long as you're right, it is the same thing, as long as you kept straight which one was changing. Okay, so on this one, we like row 1. I'm going to multiply this row by a negative, so that's going to be a -1, -2, and a -5. So this is going to give me a 0 here. It's going to give me a -1 here and a -2 here. Goal 1, goal 2 accomplished. If you do it in that order and you go column by column, you won't screw up the work that you already did. Okay, so please make sure you do them in order. So think about what the third goal is.
Wait.
What?
It wouldn't work because when I did the row 1 minus row 2, I got a regular 1. Because 2 minus 1 is just 1, not to make 0.
But this turned out to be a positive 2?
Yeah.
That's okay. You're fine.
The next step.
I win.
The hard part is, so there are tons and tons of variations to doing this. I'm teaching you 3 simple rules that if you stick with those, they're a lot easier to keep straight. We could actually do operations on columns, okay? And there are lots of them. So as long as you keep straight which one you're changing, you're okay there, okay? So I need to change that -1 into a positive 1, so what am I going to do? Take row 2 and multiply it by a negative, or divide by a negative for that matter. Doesn't matter. Okay? Which one changes? It's not the first one. We like that so far. It's that 1 that we wanted to change to a positive 1. So 0, 1, and 2. So we're almost there. All I need to do is get rid of that 2. So stop and think for just a second. Don't say anything out loud. Again, column by column. Use the 1s to make the zeros. Okay, what are we going to do?
-2R2 plus R1.
So that's going to be 0, -2, -4. So remember, we like row 2. That's not going to change. We want to get rid of that, so we're going to do 0 plus 1, -2 plus 2, and -4 plus 5. So that's going to be a 1. So our answer is 1, 2. Any questions? Everybody got that? Raise your hand if you're pretty confident. Okay. We'll do the same thing here. So we want to write down the augmented matrix. So I'll do that right next to this. Again, I struggle a little bit with my handwriting. Okay, now, if you did what I did, you probably wrote that down as an augmented matrix. But let's stop and think for just a second. What is goal number 1?
Make the 1 next to the very top 1.
Okay, we want to make that one a 1. Now, I could pretty easily do that if I took that row and I multiplied it by 1/2 or divided it by 2, if you wanted to think of it that way. That'd be pretty easy. Or couldn't I just have written down that second row in the first place? Would that be okay? Did anybody do that?
To what?
Okay, a couple of people spotted that. Notice that this one starts off with a 1. Well, can't I just write the second equation first? Can I just swap those two? Isn't that one of the rules?
You can do that?
That was one of the rules. We're glad you're so surprised. Okay? So if you wanted to do that, that would be okay. Generally speaking, that's going to work much better. Everybody watch, please. It's usually not going to happen that all of them will be multiples of the same number. Okay? On this one, if you divide everything by 2 or multiply by 1/2, every one of these is going to turn out to be a nice whole number. What if this was a 5 right here? Then it's a 1/2, right? So I'm going to start this off by doing this. Before you write down the augmented matrix, so tomorrow I'm going to hand you a piece of paper with one system of equations on it. Look at it, and if there's a 1 up there, great. If not, if there's a 1 somewhere in here, just take that row and move it. So I'm going to do 1, 1, 1, 1, 2, 2, 0, and 6. Okay, are there any questions? This is where we're going to start. Okay, I'll say this again. I mentioned I'd say this all the time. Go column by column. Focus on one column at a time. Again, this is the nice thing about this method. It frees your mind up from keeping track of everything, and all you have to do is focus on one column and the 3 goals in that column. Get the 1 where it's supposed to be, and then use the 1 to make the zeros. So we've got the 1 where it's supposed to be. We want to use that 1 to make those zeros. So Marissa, what's the first thing we're going to do?
Personally, I did -2 row 1 plus row 2.
Very good. Okay, that's probably what most people would do. So that's going to make this -2, -2, -2, -2. And if I put those together, now remember, we like row 1, right? We're not going to mess with that. This is going to make this 0, 0, -2, 4. Now, could we save ourselves some writing by doing 2 steps at once? I think we could. Let's use that 1 to make that a 0. So stop and think for just a second. How are we going to make that happen?
Do the same thing but with a -3. And different rows.
I'm glad we're all thinking to ourselves, giving everybody the opportunity to come up with that on their own. It's always nice when that happens. We're going to do exactly the same thing, except for we're going to multiply by -3, and we're going to add it to row 3. So I'm actually going to put that down here. -3, -3, -3, and -3. So pretty easy arithmetic here. If I then combine those, I get 0, 1, -4, and let's see, I get a 10 here, right? Okay, now, I want you to look at this for just a second and think about those rules we've got. Goal number 1, 2, and 3. Great. Just focusing on that column. What is the 4th goal?
The middle one.
We want that to turn into a 1. Now, there are a couple ways I can do that, both of which are relatively easy, but there's a really easy way to do it on this particular one. Okay, so we're going to do this. We're going to do row 2 swap with row 3. So I'll just put a double arrow there. And all I have to do is change places. So this is going to be 1, 1, 1, 1, 0, 1, -4, 10. And this is going to...
Oh, hey, I got that and then I stopped switching back to it.
Okay, whoops. This actually has some huge advantages. Come on. Guess I tapped that one I shouldn't have. Okay. So by switching those, look what I've got. Goal 1, 2, and 3, 4, and 5. I've got goal 6 to take care of. So we want to turn that into a 0. Again, column by column. Use the one that you have to keep in order to make the zeros that you need. Amelia, what do we do here? I want to use that 1 to make that a 0. Times the second row by -1 and add it to row 1. So that's going to be 0, -1, +4, and -10. Everybody with me? So notice that that step doesn't permanently change the second one. We haven't even touched the third one. But this does turn it into a 1, a 0, a 5 it looks like, and a -9. With me there? Okay. Well, what's wrong?
I've got a -3 right there.
Okay, you should follow along. Again, the nice thing about writing down what you've done is you can look back and make sure you did the arithmetic correctly. Goal 1, 2, and 3, 4, 5, and 6. We're now on goal 7. We're on our last column. So if we do this in the correct order, we don't have to worry about screwing up the 6 steps that we've already taken care of. All I need to do now is get rid of that -2 and make it a +1. What's the easiest way to do that? Multiply by -1/2. Or divide by -2 if you wanted to. Okay? We're going to multiply by -1/2 times row 3. Yeah.
Can't you just find Z right there?
Sure. Yeah. Do you want to find out what Z is?
Yeah.
What's Z?
-2.
Z is -2. Okay? So if you wanted to stop there, translate those other 2 into equations, be my guest. Okay? I'm going to go ahead and finish it this way. So here's what we end up with. We end up with, this is going to be 0, 0. This is going to be a +1. If I multiply that by -1/2, that's a -2. And I haven't messed with these at all. Again, if you want to go through and get it in row echelon form, 1's down the diagonal, 0 everywhere else, that's fine with me. But at this point, I'm going to go ahead and finish because the steps for finishing this off are pretty easy. They're very similar to the ones that we just did. So I'm going to take row 3, I'm going to multiply it by 4, and I'm going to add it to row 2. And can somebody tell me the command I'm going to write down or the syntax that I'm going to write down to get rid of that 5? Who can tell me that? I want to use that 1 to make that 5 a 0. -5. Row 3, add to row 1. Okay? So I'll do this one first. So that's going to be 0, 0, 4, -8. Again, I like that last row. I'm done with that one. We can read off the answer, but here I get 0, 1, and this is going to be 0, and this is going to be 10 minus 8, so that's going to be a 2. And then if I do in blue this work, this is going to be 0, 0, -5, and I'm multiplying by -5, so that's going to be a +10. So I get 1, 0, 0, and 1. Isn't that right? See, that's bad. 1, 2, -2, there's our answer. So it actually took 1, 2, 3, 4, 5, 6, 7 steps to do that one. Any questions?
Yeah. How did I do that?
This is the trouble. You gotta, I mean, if you're not sure, I would watch and follow along and do the same steps we have. If you make one simple arithmetic error, think about how many multiplication problems we did here. Think about how many addition problems we did here. And the odds of doing all of those correct. Okay?
Well, I was the exact same. All the way up
There you
until
go.
negative.
Okay. This is what the test is going to be like tomorrow. You're going to have a piece of paper. It'll have a problem on it like number 7. What's good about number 7? Already have a 1. Okay, now just a quick word before we kind of just step through this. 9 goals here. Doesn't matter how good you are at those 9 goals. If you write down the problem wrong, you're going to get it wrong. Okay? So if it takes putting a sticky note next to the problem as you're copying it down, make sure you copy it down correctly. Double check. I write them down in rows and then I double check in columns. So it should be 1, 2, negative 3, 1, 2, negative 3, negative 2, 1, 2, negative 2, 1, 2, 3, 1, negative 2, 3, 1, negative 2, and 7, 4, negative 10. I've got it written down correctly. At least I know I'm on solid ground starting this out. And then I go through and do the steps. On this one, I'm going to get this into just row echelon form. Okay? So I'm going to make that a 0 and that a 0. So I'm going to take the first row, multiply it by negative 2, and add it to row 2.
Row 2 plus row 2.
Sorry. So that's going to be negative 2, positive 4, negative 6, negative 14. Double check, make sure you got that step right. That second row should now be 0, 5, negative 5, negative 10. You okay? Sarah Allen, can you tell me the next step? I want to use that one to make that a 0. Okay, we are going to add it to row 3, but multiply by 3. Okay? So that's going to give us a 3, a negative 6, a positive 9, and this is going to be a 21, right? So if I put those together, I get a 0, I get a negative 4, I get a 7, and I get a positive 11. Doing okay? Okay, does everybody have that? Goal number 1, 2, and 3 done. If all I'm going to do is get this in row echelon form, I want a 1 here, a 0 here, and a 1 here. So I want to make that a 1. There are a couple different ways that I could make that 1. I get a little bit lucky on this one. Somebody tell me why we're lucky in the second row. You can just divide it by 5. That would be the easiest thing to do. One thing that would be a little bit more complicated, but everybody watch, please. Okay, that doesn't produce fractions when we divide. If it did produce fractions, we probably wouldn't want to do that. On this particular one, what if I took row 3 and just added it to row 2? 0 plus 0, wouldn't screw that up. 5 minus 4 is a 1. Negative 5 plus 7, that's going to be a 2. And that would be a positive 1. That would be another way to go. I'm going to go ahead and let's do row 2 multiplied by 1/5. So here's what we've got. 1, negative 2, 3, 7, 0, 1, negative 1, and negative 2. And 0, negative 4, 7, 11. I only have 2 goals left. If all I want to do is get it in row echelon form so that I can, change it back into an equation and solve, I need to use that 1 to make the 4 a 0. The negative 4 needs to be a 0. So I think about what I'm going to do with that. Again, I'm using the 1 in the second row. What do I need to add to negative 4 to make it a 0? You need a positive 4, right? So we're going to multiply by positive 4 and add it to row 3. So that's going to be a 0, a 4, a negative 4, and a negative 8. And then let's write down what we've got here and see where we are. 1, negative 2, 3, 7. 0, 1, negative 1, negative 2. 0, 0, that looks good. This is going to be a 3, and take a look at this. What's that one? Also a 3. Okay, now stop right there. Is everybody correct to this point? Everybody following along? At this point, we can almost be done with the row operations. In fact, if you wanted to stop row operations right here and say, hey, you know what? I'm now at a point where I can figure this out. I've got it to where I can read off that 3z equals 3, so what does z equal? Z equals 1. Then I look at that second equation. Everybody watch, please. I just want you to watch. Watch. This is y minus z equals negative 2. So that means y equals 2 plus z. Okay, let me move this around. Oh, it's a negative 2, thanks. Okay. Let me move this one around without writing down the whole equation to start with. This is going to be x. What happens if I move that 2 to the other side? Take that 2, it's negative 2y. Move it to the other side. It's going to be 7 plus 2y. That's going to be a 3z. What happens if I move it to the other side? Minus 3z. So if you know what z is, plug it in here. Plug it in right here. Negative 2 plus 1. What's y? Negative 1. If you know what y and z are, plug them in here. So that's going to be 7 minus 2 minus 3. And that means x is equal to 7 minus 2 minus 3? 2. So 2, negative 1, 1. There's the answer. Now, if you need to write down the equation, so the equation would have been x minus 2y plus 3z equals 7, and then move them over. Be my guest. But especially for one as simple as this, think of that, well, that's a negative z over here. Let's move it over. It would be a positive z. Okay, are there any questions? Yeah.
So if we did it the other way and added row 3 and row 2,
What do you, at what step?
the second part, second step.
Right here?
Yeah, if you added them in, then row 2 would have been 0, 1, 2, and 1.
So this row would have been 0, 1, 2, and 1. Mm-hmm.
And then on the bottom row, you would have gotten, well, you have to go through all the steps, but
It'll work out the same.
really?
Yep, it will. Promise. Yep, as long as you've done it correctly, those rules work. Okay? All right, any questions? Okay, we've got about 5 minutes left. This is the last problem on the assignment. Stop and look at that. I believe 53 is on your assignment, so you're doing a homework problem right now. Okay, I want you to look at that. Don't write anything down. Let's be smart about where we start. Could you do anything right away? Kind of do an operation before you even write down an augmented matrix?
Times them by the negative 1.
You could switch row 1 and 2 if you wanted, but that still gives us a negative 1 there. What could I, yeah, let's just times that row by a negative. So let's do row 1 times negative 1. And let's start off with 1, negative 1, negative 1, 1. The next one would be negative 1, 2, negative 3, negative 4, 3, negative 2, negative 7, and 0. Now, are there any questions on that? Okay, go ahead. Again, write down the steps you're taking as you're taking them. Who's got it figured out? Two. Okay, everybody watch.